Hey guys, this is part 2 of our video on parallel and perpendicular lines, and at the end of part 1 we talked about how parallel lines have identical slopes but different y-intercepts, and perpendicular lines have negative reciprocals for intercepts. So you flip the number. If it's a fraction, flip it over. If it's not a fraction, you make it a fraction, and you change the sign to get a negative reciprocal. And we did a little bit of practice of finding negative reciprocals. Now let's take that knowledge and apply it to linear equations. We want to write the slope-intercept form of the equation of the line perpendicular to this line, y equals negative 4x plus 9, and passing through this point. So the first thing we need to do is find the slope of our new line, the line that we're trying to write. And we know that it's perpendicular to that y equals negative 4x plus 9. So if the slope of that line is negative 4, then the line that we're trying to write must be a negative reciprocal of that. And the negative reciprocal of negative 4 is 1/4. So we put our 4 on the bottom and put 1 over the top. That makes it a reciprocal. And a negative reciprocal has an alternate sign. So if our slope here was negative 4, then our negative reciprocal must be positive here. So the slope of the line that we're trying to write actually has a slope of 1/4. And we know it goes to this point, 2, 7. We're now going to plug that information into our slope-intercept form. So here is our formula, which we will write every time. If there is a formula, always write it as your first step. Always, 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 always. We did that with the Pythagorean theorem. We did it with our slope formula. We are going to do it here. Always write the formula first and then substitute in. If you try to do the formula in your head and substitute in your head, you are bound to make a mistake by dropping a sign or forgetting a piece of it. So always write the formula first and then substitute in. Of course, as I always tell you, use parentheses when you substitute. That protects the negatives. It protects your operations. It keeps you from getting confused when you have a minus and a negative right next to each other. So use parentheses. They're just 2 little pencil marks. It won't take you that much time to add those in there. So substitute now using parentheses. So we're going to write y minus, and our first y1 value here. Remember, this is x1 and y1. I don't know why I did an I there, y1. And then our slope, which we just found, 1/4, and then x minus x1. And we're going to use parentheses there. Again, always use parentheses. We'll then simplify here. We're going to distribute that 1/4, and when we do that, we get y minus 7 equals 1/4 x minus 1/2. Remember that when you're multiplying fractions, you multiply the top, and you multiply the bottom. If there is no bottom, then your bottom is 1. So we get 2/4, which simplifies to 1/2 right here. We're then going to use our rules of algebra to get the y by itself. So we will add 7 to both sides. And we get y equals 1/4 x plus 13/2. So you can see we just added 7 here, and then we added 7 here. 14/2 is 7. We had to write it that way so that we could add those 2 fractions together with a common denominator. All right, and last thing, we want to look at these graphs, look at these slopes, and determine whether our lines are going to be parallel, perpendicular, or neither. Remember that parallel lines have the same slope, so their m's are equal. I don't know what I'm writing there. Their m's are equal, but they have different y-intercepts. Perpendicular lines have negative reciprocals. So one will be m, and the other will be negative 1/m. And it's possible that they're neither parallel or perpendicular, that they just intersect. So lines that aren't parallel or perpendicular are just intersecting lines. Perpendicular does intersect, but intersects at a 90-degree angle. All other lines that intersect, just not at 90 degrees. So let's use our slopes to determine that. We have 2 different equations here. Let's go ahead and find the slope. We can do that by putting it into y equals mx plus b, or we can also do negative a/b. This particular line, we would get negative 2/5. And you see here, that's exactly what we found our slope was, negative 2/5. Over here, our negative a/b, if we don't want to put it in slope-intercept form, is negative 4/1, or just negative 4. Right? according to our definitions, these slopes are not parallel because they're not the same. They're not perpendicular because they're not negative reciprocals of each other. So these two lines are neither parallel nor perpendicular. All right, guys, today we wrote the equation of a line using point-slope form, so a new form in addition to standard and slope-intercept. We wrote the equation of a line using a point on a line. We were given an xy coordinate to plug in, and we wrote the equation of a line that's either parallel or perpendicular to a given line. Remembering that our parallel lines have identical slopes, they just have different y-intercepts, and our perpendicular lines are negative reciprocals of each other. Negative reciprocals. Any other line that's not the same or not a negative reciprocal is just intersecting lines. Nothing special about them. If you guys have any questions, be sure to write those down for next class.